The prep assignment?
Not really. It's just I have to um, just try to understand a little bit more, but it's nothing that can be explained. I just have to put that in my head. That's all.
Yeah, me too. I think I understand it a little bit, but yeah, it's just like I just gotta study more.
It's just I just kind of get it, and then when they ask me again, I just forget it. So I go
Yeah.
again and go back and see it again and try to understand. I just have to make it in my own words to have it ready.
Uh-huh. Yeah.
Well, that
Awesome.
I think that's all. Mm-hmm.
Okay, cool. Um, should we start the quiz?
I think so. I don't have any questions.
Okay, cool. Let's see.
Did you understand everything from last week?
From last week? Yeah,
Yeah.
I do. It took a little bit to understand, but I think I finally got it.
Okay.
All right. Okay. Number 3
Yeah.
says when you are taking a sample size of n equals 5, what is the shape of the distribution of means? Histogram when the parent population is right skewed.
It's just right skew. Skewed right.
Yeah. Okay.
So number 4 says when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Would it be normal or is it right skewed?
Yeah, I think it's right skewed.
Right skewed. Okay. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal?
Normal? Mm-hmm. The 6, when you're taking a sample size of n equals 100, what is the shape of a of distribution of means histogram when the parent population is normally distributed? So this is most of when it takes us small sizes and large sizes.
Mm-hmm. So is it normal?
I think it is.
Yeah. Because it says, yeah, distribution of sample means is normal when the parent population is normal.
Mm-hmm.
I'm just assuming it takes on what the parent population says.
I was making the homework also, And it says even if they got a random sample of 4 students, for example, uh,
Mm-hmm.
but if it says that it's right skewed, is skewed to the right, the
Oh,
question. So I think it's the same thing.
that's good. Okay. Number 7. When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Data are drawn from the population that are right skewed and the sample size is large. I think it's the second one.
I says choose all correct responses.
Oh, it says choose all of them.
Mm-hmm.
Awesome.
What I saw is, and the problem is when it says that it's normally distributed, it's gonna be normal distributed. It just doesn't matter if it's a small size or it's a large size.
Oh, okay. So 1 and 2.
I think so.
Okay. All right. Number 8.
Okay, just give me a second. I don't know. Just getting confused now with this. Okay, number 8 it says which of the following gives the best explanation about of the central limit theorem? If the parent population from which the data is drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of data will be within one standard deviation of the mean. About 95% of the data will be within two standard deviations of the mean, and approximately 99.7% of the data will be within three standard deviations of the mean. If the sample size is large, the sample mean will be close to the population mean. If the sample size is large, the shape of the distribution of the sample mean will be approximately normal.
I think it's the last one,
Hmm.
right?
So if this theorem gets like if it's large, if the size is large, the shape will be normal.
Mm-hmm.
So if it's a small, what that
Then,
could be, because of the questions and the top it says if it says normal distributed, but the sample is small. That is,
I don't know about
I
the
think if
small
it
ones.
says it's normal distributed, even if it's a small one, it has to be normal.
If it's small,
Because like
maybe did the
the number five is small. The sample size is small. It's five. So, but it
mm-hmm.
says that is normal distributed. So I think if it says that it's normal distributed, so the shape will be normal. Because it doesn't say
Yeah,
that it's small to the left or it's small to the right, or to give more information to know
yeah. The
guidance.
I think they just compare it to the what's it called, like the population
Mm-hmm.
size.
Mm-hmm.
I think they compare the sample size to that, and if it's like larger than the mean, I guess it would be, then it would be approximately normal. So they give, I think they just give like you the number, like this is the norm or whatever. And if it's larger than that, then you just assume it's approximately normal.
Mm-hmm. Okay.
At least that's what I understood from the
Yeah.
reading.
It's just what I say. I go back and I get confused and then go back again to see
Yeah.
until I got the question.
Uh, okay, let's see. So number 9.
Mm-hmm.
Let x be a random variable with population mean mu equals 10 and population standard deviation equals 6. Suppose a sample of size n equals 36 is drawn from this population. What is the mean of the distribution of sample means? 10?
Yeah.
Okay.
So number
What
3,
is
what is the standard deviation of the distribution of sample means?
6? Or is that the equation?
I think so.
That's the equation.
Yeah. How we know when we have to do the equation, and how we know when we don't. 'Cause
Um.
all the examples I got, I have to do it. So
Mhm.
I have to know when I have to do it. And
Yeah, I think when it says standard deviation of the distribution of sample means, I think it's when you use the equation.
okay,
Yeah.
I got it.
So,
See, I just got that part and I have it already, but I just forgot. So
let's
it's
see.
gonna be 6 divided by the square of 36.
Yeah. That's 6.
Good one.
Yeah. I got one too. Okay. 11. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape distribution of sample mean? So, yes, if the sample size is large, I think it would be approximately normal.
Mm-hmm.
Yeah. Okay. Then number 12. Theorem would justify a response to the last question. The
The
central.
large number?
Would it be a large number?
I think so. What do you think? Because as okay, yeah. What will be the shape distribution of the sample mean?
I think it's central limit theorem
Because
because I remember.
central limit is doing with shaping the
Yeah, isn't that the central limit theorem?
uh-huh.
Yeah.
The
So would
other
number
one is
12
just
be that?
saying that it just get closer to the mean of the population mean. I think yeah, central limit here.
Okay. Awesome.
Let's see.
Resubmit this.
Yeah, we got 91%.
Boom.
Did we miss one?
We missed about 2, so we missed question 4
Okay. 7.
and 7.
Okay. Okay, so if the sample is large, that's what I said. I don't know. If the sample is large,
For what number?
it has to be normal.
Or number 7?
Or,
Number 4?
and there were another one.
Number 4 would be normal, right?
I think so. And what is number 16? If number 4 is normal,
Well, number 6 we got right. It was normal.
yeah, I just want to compare number 3 and 5 and see what is the difference to know the shape of the extrusions. Okay. Okay. So when it says that it's right skewed or left skewed, if the sample is small, it has to be right or left skewed.
Oh, okay.
Sample is large, it has to be normal.
Oh, okay.
So, and the number 5, the sample is small, but it says that the parent population is normal distributed. It doesn't matter if it's small, it's large. The shape will be normal. So I think it is like that or no.
Okay.
The number 3 is it says that it's right skewed and it's a small size. Uh,
Mhm.
the number 4 it says that it's right skewed, but it's a large size. So, like the central limit theorem says that if it's larger, it gets the shape gets normal. So I think that's why we got wrong.
Mhm.
Yeah, it should be normal. The number 4
Yes.
and the number 7. The number
And
7 has to be with that also. I think because if the population is right skewed, but the sample is large, so the shape will be normal.
so you're saying it's 1, 2, and then the fourth one?
Mm-hmm.
Yeah. Yeah, if the sample size is large, it'll be
Yeah,
normal.
it's the same as the examples of the number what 3 and 5.
Mhm.
It were right
Okay.
skewed, but one is a small uh, size,
Mhm.
and it gets right skewed. And if it's large size, it has to be normal. Now I got it.
Awesome. Okay. Let's do this again.
Yep.
Okay. Number 3. We're taking a. So that one is right skewed.
Yeah. It's a small size and it's right skewed. It gets the same. The number 4 is larger size and it's skewed, so it gets normal.
Normal.
Mhm. So number 5, it says that it's normally distributed, so it's normal even if it's a small size.
Okay. And then number 6 is normal.
Yeah.
And number 7, we said it was the first, second, and fourth one.
Mm-hmm.
number 8.
Number 8. Which one explains the central limit theorem? Mm-hmm.
Okay. Number 9.
Number
Mean
9
is
is
10.
10.
And that was 1.
Mm.
So number 11 was normal.
Yeah.
And then central limit.
Okay.
Awesome. Okay, should we submit it again?
Yeah. There we go.
Awesome.
This helps me to understand more.
Uh-huh.
Yeah, now I got it.
Okay, cool.
Better.
Awesome. Well, then I will post the link onto that discussion board. I guess that's what it's called.
It has to be just one, right?
Yeah, it's just one of us, and we just list off the names.
Okay. Yeah.
Yeah. So is Thursday still good?
Mm-hmm.
Okay, perfect. Awesome. Well then, I will see you then.
Okay. Have a good night.
You too.